Let's go ahead and practice finding the LCM of two numbers together. And specifically in this video, we're going to use the prime factorization method for half of the problems, and then we're going to use the ladder method for the other half of the problems. And if you weren't already aware, you can go ahead and download a free copy of this blank PDF from the description of this video, as well as check out the annotated answer key PDF if you need to as well. To show you both of these methods for finding the LCM, or least common multiple, I'm going to use the prime factorization method for every odd practice problem and the ladder method for every even practice problem. Let's give it a go. So for number 1, we have 4 and 3, so using the prime factorization method, the prime factorization for 4 is just 2 times 2, and the prime factorization for 3 is just 3 because it's a prime number. Then to find the LCM, what we're going to do is we're going to look for any common prime factors that they have, but notice that they don't have anything in common. Now they do have a 1 in common technically because you can multiply anything by 1, but that's basically it. So their GCF would be 1, but for the LCM, we don't have anything in common, but we do have some extra numbers that we can multiply together here. So this was not in common, this was not in common, and this was not in common. If you go ahead and multiply 2 times 2 times 3, what we're going to find out is that the LCM here is going to be 12, because 2 times 2 is 4 and 4 times 3 is 12. All right, so if they have something in common, we'll deal with that in just a moment, but if they don't have anything in common, just multiply all the prime factors together. 12 will be the first time these two numbers meet. For number 2, I'm going to use the ladder method instead. So I'm going to go ahead and put the 5 and 2 right next to each other, 5 and 2, and go ahead and set this up using the ladder method. And think of any factors that they have in common. 5 and 2 have nothing in common, so you're going to say that 1 is their GCF, just like in number 1. 1 times 5 is going to be 5, so we're going to be left with a 5 here, and 1 times 2 is 2. And notice that 5 and 2 have nothing in common here, so if we go ahead and multiply all the outside numbers here, all right, if we go ahead and multiply 1 times 5 times 2, that's going to be 10, so the LCM here is going to equal 10. For number 3, let's go ahead and use the prime factorization method. So for 4, the prime factorization is going to be 2 times 2, and for 6, the prime factorization is going to be 2 times 3. So let's see how this one's a little bit different than number 1, but you have to look and see what do they have in common, if they have anything in common here. So notice how they do have these 2's in common. Okay, so that's going to be part of the LCM, but it's also the GCF because they have nothing else in common. So what we're going to do for the LCM is we're going to start off saying, okay, we have the LCM. We know it's going to be 2, but it's going to be multiplied by something else. So besides what they have in common, what do they have extra? Well, they have a 2 and a 3, and we're going to go ahead and multiply by these extra numbers here, 2 and 3. So 2 times 2 is 4, and 4 times 3 is 12. So the LCM here is going to be 12. So in number 1, they had nothing in common besides 1, but in this problem, they had the 2's in common, so you have to find their GCF before you find the LCM. For number 4, let's go ahead and use the ladder method for 6 and 10. So 6 and 10, write them next to each other. And our goal is to see what they have in common. So since 6 and 10 are both even, we know 2 goes into them. So 2 goes into 6 3 times, and 2 goes into 10 5 times. And so we're left with 3 and 5. And I think 3 and 5 have nothing in common besides 1. So we can go ahead and multiply these outer numbers here. Kind of makes like an L, right? And then so 2 times 3 is 6 times 5 is going to be 30. So the LCM here is going to equal 30. That's the first multiple where 6 and 10 meet. For number 5, let's try using the prime factorization method. So we have number 5, its prime factorization is just 5. And for 4, its prime factorization is 2 times 2. So notice they have nothing in common, so we know that their GCF is going to be 1. So if we're going ahead and writing our LCM down here, the LCM, it does have this 1 that they have in common here. But then what were the extras? Well, the extras here were going to be this 5, and this 2, and this 2. These were the extras, right? So 5 times 2 times 2, 5 times 2 is 10, 10 times 2 is 20. So we're going to have 5 times 2 times 2. And 20 is going to be the LCM, or the first time that 5 and 4 meet. For number 6, we have 7 and 3. So 7, we're going to use the ladder method for this one. So we have 7 and 3. And what do they have in common? Well, I think they just have 1 in common. 1 times 7 is going to be 7, and 1 times 3 is 3. And I think 3 and 7, again, have nothing else in common. So we're going to go ahead and multiply these outer numbers together. So 1 times 7 is 7. 7 times 3 is 21. So the LCM here, or the first time 7 and 3 meet, is going to be 21. For number 7, we have 8 and 6. Let's try using prime factorization. So 8 is equal to 2 times 2 times 2, and then 6 is equal to 2 times 3. All right, so we're going to start off seeing what they have in common. And so let's see what they have here. I do see that they have these 2's in common, right? These 2's right over here. And then what else do they have in common? I don't think anything else. So for the LCM here, we're going to start off saying, okay, they have these 2's in common, but then you have to go ahead and multiply by all the extras. So this 2 and 2 and 3. So if we multiply by 2 and 2 and 3, 2 times 2 is 4, times 2 is 8, times 3 is 24. So the first time 6 and 8 meet is going to be 24. That's the LCM. For number 8, we have 9 and 6. Let's go ahead and try using the ladder method. So again, you put 9 and 6 next to each other. Think to yourself, what number goes into 9 and 6? Think about your multiplication facts. If you're thinking of 3, that is a good number to use. 3 goes into 9 3 times, and 3 goes into 6 2 times. So we have this 3 and 2 left over. I don't think they have anything in common here. So we're going to go ahead and say, okay, we have 3, 3, and 2. 3 times 3 is going to be 9. 9 times 2 is 18. So we know the LCM here is going to equal 18. First time that 9 and 6 meet. Let's check out number 9. For number 9, we have the numbers 12 and 9. So let's see. For number 8, we just use the ladder method. So let's use the prime factorization method. So we have 12, that's equal to 2 times 2 times 3. And 9 is equal to 3 times 3. So let's see, do they have anything in common? Yes, they have these 3's in common. So for the LCM here, we know that they are going to start off multiplying by what they have in common, which is this 3. And then let's see what they don't have in common, right? What they don't have in common is this 2 and 2 and 3. So let's multiply what they have in common by what they don't have in common. All right, so 2 times 3 is 6, 6 times 2 is 12, 12 times 3 is going to be 36. So the first time they meet is 36. For number 10, let's go ahead and use the ladder method. Let's do 10 and 8. And let's see what they have in common. It looks like they're both even numbers, so we can put a 2. 2 goes into 10 5 times, and 2 goes into 8 4 times. And I think they have nothing else in common, this 5 and 4. And so we can go ahead and multiply these numbers. So 2 times 5 is 10, times 4 is 40. So the LCM, or the first time these numbers meet, is going to be 40. All right. For number 11, we have 9 and 4. Let's use prime factorizations. 9 is equal to 3 times 3, and 4 is equal to 2 times 2. Interesting, they have nothing in common, so keep in mind that they do technically have these 1's in common. So when we're writing the LCM out, the LCM will have equal to, we do have 1, which is their GCF, don't forget that. But then remember, everything's kind of an extra here, right? So 3 times 3 is 9, 9 times 2 is 18, 18 times 2 is 36. So we bring everything down. And you can remember that in future maybe, that if they have nothing in common, you can just multiply them together, and that'll get you the LCM as well. For number 12, we have 15 and 6. Let's try the ladder method. Put them next to each other. Ask yourself, what goes into 15 and 6? I think we could use a 3 here. 3 times 5 would be 15, and 3 times 2 would be 6. And I think that's it. 5 and 2 have nothing else in common besides 1. And so if we go ahead and multiply these numbers on the outside, they make this kind of L shape. 3 times 5 is 15, 15 times 2 is 30. So we can say the LCM here is equal to 30. For 13, let's go ahead and try using the prime factorization method. So we have 16 is equal to 2 times 2 times 2 times 2, and 8 is equal to 2 times 2 times 2. All right, let's see what they have in common. Well, they both have a 2, they both have another 2, and they both have another 2. So if we're going ahead and writing this, we actually just found our GCF, right? So 2 times 2 is going to be 4, times 2 is going to be 8. So we're going to have 8 when you combine all of those ones, which is our GCF technically, right? And then multiply by the extra, which is this 2, okay? So 8 times 2 is 16, which kind of makes sense, hopefully, because 16 is the first multiple of 16, and 16 is the second multiple of 8. So that's what happens in this one. All right. For 14, we have 18 and 6. Let's see what happens if we use the ladder method this time. 18 and 6. See what they have in common. There's a few things you could choose from here, but maybe I'm going to choose 3. Let's go with 3 here. 3 times 6 is 18, and 3 times 2 is 6. And then 6 and 2, they still have something in common here. I think they both have a 2 in common, right? So 2 goes into 6 3 times, and then 2 goes into 2 1 time, and I think that's it. Now for the LCM, we're going to have 2 numbers on the side and 2 numbers on the bottom, but if we multiply all of them together, that should get us our LCM. So 3 times 2 is 6, times 3 is 18, times 1 is still 18, so the LCM here is going to be 18. All right, the first multiple of 18 is 18, and the third multiple of 6 is going to be 18. For number 15, let's go ahead and use the prime factorization. So 15 is equal to 3 times 5, and 10 is equal to 2 times 5. So do they have anything in common? Yep, they have these 5s in common. So if we're going to go ahead and start the LCM starts with what they have in common, their GCF, which is 5. And then we're going to multiply by all the extras. So we have a 3 and a 2. So if we multiply by 3 and 2, 5 times 3 is 15, and 15 times 2 is 30. So 30 is the first time they meet. For number 16, let's go ahead and use the ladder method. We have 20 and 15. So what do they have in common? Hopefully, if you know your divisibility rules, you're thinking of 5. 5 goes into 20 4 times, and 5 goes into 15 3 times. And I think 4 and 3 have nothing else in common. And numbers that are right next to each other never have anything in common, like 4 and 3 are 1 apart. So 5 times 4 is 20, and 20 times 3 is going to be 60. So the LCM here, the first time 20 and 15 meet, is going to be 60. Alrighty, number 17, let's try prime factorization. For 17, 24 is the same thing as 2 times 2 times 2 times 3. And 16 is equivalent or the same as 2 times 2 times 2 times 2. What do they have in common? Well, they have these 2's in common, another pair, and another pair. So what is 2 times 2 times 2? That's 8. So if we are going to go ahead and write this, we know that LCM is going to start with 8. That's their GCF, but then it's got to multiply by the extras, so 3 and 2. So 3 times 2 is 6, and then 6 times the 8 is going to be 48. So again, use the GCF and multiply it by the extras. That's the process here. For 18, we have 18 and 4, so let's use the ladder method. They're both even numbers, so I'm going to start with a 2. 2 goes into 18 9 times, and 2 goes into 4 2 times, and then I think that's it. So if we go ahead and multiply these outer numbers, 2 times 9 is 18, 18 times 2 is 36. So the LCM here is 36. For number 19, we have 11 and 6. Let's use prime factorization. For 11, that's just 11 because it's a prime number. And for 6, that's just equal to 2 times 3. Notice they have nothing in common, so we can do a times 1 times 1. So if we're writing out the LCM, their GCF is equal to 1 because that's all they had in common. And then we go ahead and see, okay, they had that in common. So I'll go ahead and circle it just to be consistent with the last one. And then we can circle these extras, right? So the extras are 11, 2, and 3. So 11 times 2 is 22, times 3 is 66. So that's the first time they meet. And again, if their GCF is 1, you can just multiply 11 and 6 to get the LCM. That always works if their GCF is 1. Let's try number 20. For number 20, we have 12 and 18. So what are we using here? We're going to use the ladder method, right? So let's use 12 and 18. They're both even numbers, so you could divide by 2, but I'm also thinking maybe we can divide by 6. 6 goes into 12 2 times, and 6 goes into 18 3 times. And I think 2 and 3 have nothing else in common because they are 1 apart from each other. So if we multiply these outside numbers, we should get the LCM. So let's see, 6 times 2 is 12, and 12 times 3 is 36. So the LCM is 36. For 21, let's try prime factorizations. So we have 22, that's equal to 2 times 11. And for 33, that's equal to 3 times 11. So what do they have in common? They have these 11s, that's one pair. And so for the LCM, we're going to start off saying, okay, we do have 11 as their common, that's their GCF. and then we go ahead and multiply by the extras. So multiply by 2 and 3. So 11 times 2 is 22, times 3 is 66, so the first time they meet is 66. For number 22, let's go ahead and use the ladder method. We have 20 and we have 60. So they both end in 0, so let's just pull out a 10 right from the beginning. 10 times 2 is going to be 20, and 10 times 6 is going to be 60. And then 6 and 2 are both even numbers, so let's pull out a 2. 2 times 1 is 2, and 2 times 3 is 6. And I think that's it. Once one of the numbers is 1, you can't do anything else with them. And so let's go ahead and multiply these numbers. 10 times 2 is 20, times 1 is still 20, times 3 is going to be 60. So the LCM here, least common multiple, is 60. For 23, we have 9 and 21. Let's try using prime factorization. So 9 is equal to 3 times 3, and 21 is equal to 3 times 7. So what do they have in common? They both have these 3's. So let's go ahead and start the LCM here. LCM is equal to 3 times, what are the extra numbers? So that's the GCF. And then we have these two extras. We have 3 and 7. So let's see, 3 times 3 is 9, times 7 is 63. So that would be the first time that 21 and 9 meet. For 24, let's go ahead and use the ladder method. So we have 14 and 6. And they're both even numbers, so I'm going to just start with a 2, nice and easy. Half of 14 is 7, and half of 6 is going to be 3. And I think 7 and 3 are both prime numbers, so they can't have anything in common besides 1. So let's see, 2 times 7 is 14, and 14 times 3 is going to be 42. So the LCM here, we can write LCM is equal to 42. Alrighty. 25. For 25, we have 32 and 16. We are using the prime factorization method for this one. So for 32, let's break it down into its prime factors. Turns out that 32 is 5 2's in a row, right? And 16 is just 4 2's in a row. So if you've done those enough times, you will just have them memorized maybe. So what do they have in common? They have 1 pair, 2 pairs, 3 pairs, and 4 pairs. So let's see, the LCM is going to be, well, what's 2 times 2? That's 4 times 2, it's 8, times 2 is 16. So 16 is the first part, that's their GCF. But then what's extra? This 2 is extra, okay? So 16 times 2 is going to be 32. All right, that is the LCM here. So again, multiply the GCF by the extras. For 26, we have 8 and 28. And we're going to use the ladder method here. So the ladder method, what do they have in common? You can use 2 if you'd like to start. 2 times 4 is 8, and 2 times 14 is 28. And then they're both even again, so that means we can take out another 2, which means we really could have taken out 4 from the beginning. We're left with 2 and 7. We'll be stuck there. And if you go ahead and multiply these out, 2 times 2 is 4, times 2 is 8, times 7 is going to be 56. So the LCM here would be 56. All right. For 27, we have 50 and 10. So let's do prime factorization here. So for 50, that's equal to 2 times 5 times 5. And for 10, we have 2 times 5. All right, what do they have in common? They both have a 2. That's 1 pair, and they have another pair over here. So what is 2 times 5? 2 times 5 is 10. So the LCM is going to start off with 10, which is their GCF, and then it's going to multiply by whatever's extra. So 10 times 5, so 50 is the first time these two numbers meet. For 28, we have 36 and 27. Let's try using the ladder method. So 36 and 27. Let's see. I think we can use 9, right? 9 times 4 is 36, and 9 times 3 is 27. If they have nothing else in common, then we are all done. 4 and 3 are next to each other. And so we can go ahead and multiply these numbers out here. And let's see, 4 times 3 is 12. 12 times 9, I think, is 108. The LCM here is 108. Cool. So a little bit bigger numbers, but if we already feel good about multiplying or using a calculator to multiply, then that should make that a little bit easier. All right. For 29, let's use prime factorizations. So I'm going to try to break this 80 up. I believe it's 2 times 2 times 2 times 2 times 5. And for 48, I believe that's 2 times 2 times 2 times 2 times 3. What do they have in common? Okay, looks like they have 1 pair, 2 pairs, 3 pairs, and 4 pairs. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So we do have 16 for the GCF, but what are the extras, the 5 and 3? So we have a 5 and a 3 as well here, right? So if we go ahead and multiply 16 times 5, that's going to be 80. 80 times 3 is going to be 240. So the first time these two numbers meet is going to be at 240. Let's check out these last few. So for 30, we have 63 and 42. Let's try the latter method. So 63 and 42. Let's see what they have in common. You got to know your multiplication facts a little bit more for this one. So I'm thinking maybe 7 here. 7 times 9 is 63, and 7 times 6 is 42. And so let's see, 9 and 6, I believe, still have something in common. They have a 3. 3 times 3 is 9, and 3 times 2 is 6. So I think that's it. Let's go ahead and multiply these outside numbers here. So 7 times 3 is 21. 3 times 2 is 6. What's 6 times 21? 6 times 21, I think, is going to be 126. So the LCM here is going to be 126, the first time these numbers meet. For 31, let's try 72 and 48 using prime factorization. So 72, that's equal to 2 times 2 times 2 times 3 times 3, I believe. And then 48 is equivalent to 2 times 2 times 2 times 2 times 3. Again, feel free to practice making your factor trees. I'm just doing these a little bit quicker and not writing the trees out right now, but feel free to pause and make the trees to make sure you can write each of these prime factorizations. So we have 1 pair, a 2nd pair, a 3rd pair, and we do have a 4th pair here. So 2 times 2 is going to be 4, times 2 is 8, times 3 is going to be 24. So if you're wondering what the GCF is 24. For the LCM, what we're going to do is we're going to multiply the GCF by these extras. So we have 24, and what's the 3 times 2? That's 6. So 6 times 24 is going to be 144. So the total here, or the LCM, is going to be 144. That's going to be the 3rd multiple of 48 and the 2nd multiple of 72. For 32, let's end on a ladder method here. So a little bit less writing, but you gotta have to think a little bit more maybe. Let's see, for 60 and 45, they're both ending in 0 and 5. So by my divisibility rules, I know I can divide them by 5. Turns out 5 times 12 is 60, and 5 times 9 is 45. Looking at 12 and 9, I believe you can divide them both by 3. So 3 times what is 12? 3 times 4 is 12, and then 3 times 3 is going to be 9. So I think that's it, because 4 and 3 are next to each other. So we go ahead and multiply these extra numbers together. They should give us, or not extra, the outer numbers, that should get us our LCM. So 5 times 3 is 15. 15 times 4 I know is 60, and 60 times 3 is going to be 180. So the first time these numbers would meet would be 180. So there you have 32 different practice problems on finding the LCM. Hopefully you noticed that you actually find the GCF along the way to finding the LCM, and that you feel a little bit more comfortable with these two methods. Some cases one's easier than the other, but it's also a personal preference. If you found this resource helpful, please consider giving it a thumbs up and letting me know in the comment section down below which method you like more. And as always, keep up the great work that you're already doing, and I'll see you in the next one.